All right, guys, let's review. And we'll go to slide 1, or really slide 2. There we go. Need to get this a little bit bigger. I find just the right size here today. All right, I think that's good. All right, so almost everybody marked A and B are supplementary. That's P. Then the angles add together. That's Q. So we definitely know that this is Q. How do I make the symbol for and? Is it the squiggle line, or the up arrow, or the down arrow, or the 3 dots? How do I represent and? So I'm going to have Q, the up arrow. Absolutely. This one's the and. So it's the A without the crossbar. And then I need to put my Q because they're supplementary. This one's negate. This one is or. You can put that ice cream cone on top. That's the or. This is the and. You can kind of make it into an A. And then like yesterday, we talked about the therefore. It has 3 E's. That's how I remember it, the therefore. Okay. So we definitely have to know those 4 symbols. Number 3, we haven't done very many of these, really, if at all. I was super happy with what I saw. Some people kind of estimated, we've talked about kind of sector area now, and put some dots in here. So they're equidistant. Maybe I need another dot in there. No, it's harder on this side. This is what we would normally do with a compass, but because we haven't been able to practice with the compasses, so I've got 1 and 1 and 1 and 1. I just try to find the middle of it. And I think because I added an extra 1 in here, it needs to be K. You'll also have a ruler, and next week we will use, we'll go into TestNav and practice with the ruler. You can kind of use the ruler to answer this question too, or you can just kind of eyeball it. So some people are good at eyeballing it, and just like that's K. Okay, that's the 3rd part of our equilateral triangle, or the 3rd point in our equilateral triangle. So lots of ways to do that. You're just going to have to kind of use your best estimating skills on some of those because we haven't practiced with the constructions. This one's so excited that everybody drew a triangle. I always kind of draw an equilateral triangle, even though that one doesn't really look equilateral. And then I mark everything I know. So stage A, B, and C are the corners of my triangle, right? The 3 stages are arranged in a triangle, so they're the corners. So between A and B is 100 yards. Between B and C is 135 yards. And then between C and A is 210 yards. Literally, when you have a problem like this, close your eyes, imagine it. You're at something in the water and they've got 3 major stages. They're arranged in a triangle and they're this far apart. So imagine that this is down at the ocean front. You're sitting, listening to Pharrell and Friends. It's so fantastic, right? The next problem with this question is it's asking for descending order. Descending means go down. If you don't know that word, that's a problem. So we use that a lot in middle school. But if you haven't used it in a long time, I think about stairs. I'm descending the stairs, going down. So we want to start big and then go small. So we want the biggest, the medium, and then the small. So the biggest is going to be the B. The medium is going to be the A. And the large, or the small, is going to be the C. That is my descending order, B, A, C. Does that make sense? Check yours, add it if you need to. On these questions, it sounds weird, but we talked about inscribed things, right? So I create a box around, oops, I need my pen. I create a box around the triangles. So on your Pear Deck, I want you to draw a box around your triangles. Makes me frustrated that I can't change the line thickness on Screencastify, right? How big is that box? What are the dimensions of that box around the first triangle? Did somebody say 3 by 3? Yeah, absolutely, 3 by 3. So if I come down here and I do the exact same thing and I make a box inscribing this triangle, if those triangles are congruent, the boxes should be the same size. They don't have to be the same orientation, but they should be the same size. Are those boxes the same size? Oops, that's not the 4. That's the 4, and that's the 3. So I've got one that's 3 by 3 and one that's 4 by 3. So are those going to be congruent or not congruent? Congruent means they're exactly the same in every way. So those guys are not congruent. The slope between these 2 points is not replicated over here anywhere. There's no slope of 2, 3. And there's no slope of 1, 4. So those sides are not going to be the same. Does that kind of make sense? It's like a little hack for that kind of question. Number 6, I'll be honest, if I was taking an SOL or a district test, I would save this one for the very end. Mr. Grant has a tree farm in the shape of a square. So automatically, I know because it's a square that I've got 4 equal sides and I've got right angles. So now I've got a right triangle. That's why it's a right triangle question. Half the farm has trees that are used to make pencils and the other half are used to make maple trees. So that's irrelevant. The farm is divided into 2 equal sections along the 400-foot diagonal shown. What is the length of one of the sides of the tree farm? So I've got a side here and a side here. Well, automatically, I think right triangles, Pythagorean theorem. So a squared plus b squared equals c squared. My hypotenuse is always the c, so I'm going to put the 400 here. And these sides are both the same, so I can make that s squared and s squared. If I have 1s squared plus 1s squared, that gives me 2s squared equals, and 400 squared is 16, because 4 squared is 16, and then I've got to double the number of zeros. So instead of 2 zeros, I've got 4 zeros. You can check that in the calculator. So now I got to divide. We're going to divide by 2. S squared equals 80,000. Somebody check that in the calculator and make sure I did that right. And then we've got to take the square root to get the S by itself. So this is really an algebra question, not a geometry question. And we haven't had a chance to practice as much algebra as we would normally. So this does become kind of a difficult question. Again, I would save this until the end because there's a lot of things that you need to know and pull together. Once I do the square root of 80,000, I get 282. So S equals 282. Under normal circumstances, we would also have talked about radicals, and we haven't done that. So you're going to have to change any radicals you see into decimals. Does that kind of make sense? How do we feel about that as far as algebra goes? I'm looking at the chat. Nobody? Okay. Are you guys still with me, or have you gone back to sleep?
We're still here.
You're still there. Okay, good. I was going to say, if I don't get any answers, I know everybody's back asleep. It is a cold morning. At least there's a little bit of blue sky. All right. Complete proofs. Everybody hates proofs. I don't hate them, actually. I kind of like them. I think they're like a puzzle to solve. So I've got all of these things, which I see up here next to the word given. So I'm going to write given here. Kind of the no-brainer part of the question. Reflexive property. Oh, I know what that is. That's where it takes up the same space. So which side of those 2 triangles take up the same space?
AB.
AC is congruent to AC. So it sounds weird, but AC in the B triangle is exactly the same as AC in the D triangle. I should probably mark all this other stuff too. So AD and BC were the same, and AB and DC were the same, right? So I've got all these sides marked. That's what I put here. I only have sides. I've got a pair of sides here, and a pair of sides here, and a pair of sides here. Only thing marked is side, side, side at that point in the proof. Now in line 4, I start giving you some angles. So BAC is this guy up here, and DCA is this guy here. What kind of angles are those? What am I writing? All turn at interior. Those are alternate interior angles. And we can do the BCA, this one, and DAC, this one. Those are alternate interior angles. They make the Z, right? And then AB is parallel to DC. AB is parallel to DC. And AD is parallel to BC. The drawing starts getting a little cluttered because we've got a lot of information about this parallelogram. But this is just definition of alternate interior angles. Okay, whatever this one is, you're going to have a definition down below. And then line 6 is just empty. We don't need that. So when you get questions like this, just take it one step at a time and fill out as much as you can possibly fill out. Wow, my voice is crazy today. All right, we ready to go to slide 8? In the absence of a yes, we're going to go. Steve has a circle with a diameter of 4 inches. There's no picture here, so you need to draw one, right? So Steve has a diameter of 4 inches. And this is Steve. Take the time to draw the picture. And a central angle of 90 degrees. So I've got 90 degrees. Tina has a circle with a radius of 2 inches. And this is Tania. Radius of 2 inches, and it's divided into 4 sectors that are congruent. Okay. So if I divide 360 into 4 sections, they're all 90 degrees, correct? Draw and label Steve and Tania's circles. Compare the arc lengths between the sector created by the 90-degree central angle in Steven's circle and one sector in Tania's circle. How do they compare? This piece and this piece. They both 100% do have a 90-degree angle. So they both have 90 degrees. And what else? Absolutely. The diameter is half of the radius. So are these congruent? Yeah, they're the same, exact same circle. One just drew it with a radius and divided it into 4 sections, and one did the diameter and marked the 90 degrees. Exactly the same circle, just 2 different ways of looking at it. All right, last and final question. What is the area of the shaded sector? So, what is the area of the shaded sector? How do I go about starting sector area questions? What formula do I need to set up? It's something times something else.
It's the whatever number the angle is divided by 260 times pi times your radius and square.
Awesome. What's my angle here? Because if you're going to make a mistake, that's where you're going to make it. What's the angle? If this white angle is 140, what's the gray angle?
Did you do 360 minus that 140?
Yes, ma'am. So 360 minus 140 is 220, if my mental math is right. So I'm going to change my angle to 220. So slow down when you get to these questions. You need to make sure you're actually answering the question being asked. If it's the shaded angle, then you need to find the shaded angle. And then just like Victoria said, the radius is 5. Make that pi look a little better. So 5 squared. And now it's just calculator work, right? So the translating is the hardest part. 220 divided by 360 times 3.14 times 25, or 5 squared, gives me, what does that round to?
27. Well, basically 48.
Basically 48, absolutely. And that would be centimeters squared. Okay. Questions on that, guys? I know some of these warm-ups are getting really extra. All right. Let me go back to Schoology. We did not finish the notes yesterday. So I got several messages saying, Miss Doherty, I cannot do the homework. No, you could not do the homework yesterday. So hopefully not very many people labored over it for very long before you figured out that there were only about 5 problems of the 10 that you knew how to do. So let's open Tuesday's folder. And I'm going to this circle segments link. And I give you the Pear Deck so you can open that. And let's finish these notes and then we'll do that homework together. Sound like a plan? So if I did my job right, you have this in a Pear Deck. Is that the Pear Deck that I just put in the chat? Did it take you to the one that you were working on yesterday?
Yeah.
Okay. Or you can go through yesterday's folder, go into the page, and then scroll down. My computer would go and click on the link here. It should be the same link. And we're just doing this Google Slides. Okay. So just to remind ourselves, tangents touch the circle at one point. Secants seek something outside the circle. So they're going outside the circle and outside the circle in both directions with a line. And then chords are something that connect. Chords are tight. They make things strong. So the chord has endpoints on the circle center or on the circle edges. Diameters are special chords that go through the center. So these are all kind of new words that we kind of need to know. So we had 4 examples. The first example was like the ice cream cone. If it looks symmetrical on a circle, it probably is, even if it's not marked. So this only applies to circles and really only while you're in level 1 geometry. When you get up into higher maths, that won't be true anymore. But if it looks symmetrical for this class, it probably is. So our 2 sides of the ice cream cone are exactly the same. If you have an X, you can use a proportion. So you take the A and the B and you multiply them together. You take the B and or the C and the D and you multiply them together and you set them equal. Those were our first 2 examples. We looked at those yesterday. So in your Pear Deck, you should have notes here. If this is 80 and this is 80, we can find this little part up here by subtracting 119 minus 80. And we can find this piece over here by doing 202 minus 80. Does everybody have that part? Hopefully. And then over here, we set these 2 things equal as well. Okay. So that was our ice cream cone example. That was example number 1. It's the easiest one. Example number 2 is here, and we were rushing through this. So even though many of you probably have this written down, I'm going to do it again. We've got a diagonal here, so we multiply those two things together. X times 10 is 10x, and that's going to equal the other diagonal, 14 times 15, or 15 times 14. So if I pull up my calculator and I do 15 times 14, I get 210. And then you're just going to divide by 10 and divide by 10. So x equals 21 in that example, right? We'll do the same thing over here. We'll multiply that diagonal, but now we've got to do some distribution or distributive property. So 27 times x plus 5. I always put the whole number first, okay? It doesn't have to be, but it makes I think it makes it easier to look at. And then you're going to take that other diagonal. So the whole number is the 24. 24 times x plus 7. And then you're just going to do all of the fantastic algebra you learned last year. So we're going to distribute that 27, and we get 27x plus, and then anybody with a speedy calculator, what's 27 times 5?
135.
Awesome. And then we're going to distribute on the other side. 24 times x is going to be 24x. It's a 5, by the way. And then 24 times 7, it's going to give me 168. Again, I know some of you already have this, but I want to make sure everybody does. There's a lot of ways to solve this. I always subtract my smaller variable because I'm kind of allergic to negatives. I make mistakes when I have negatives in there. So that one crosses out, and 27 minus 24 is 3x. If I move my x's to the left, I want to move my numbers to the right. So I'm going to minus the 135 from both sides. That means they go away on the left side. And 168 minus 135. Did you get 33?
Yes.
And then you divide by 3 and x equals 11. Questions on example number 1 or example number 2? All right. The next two are tough. So if you had a little mental break because we were reviewing, like put all of your focus and energy into the next two. They're not really that hard. They're just, you got to pay attention to the detail. Okay. So if you look down here at the bottom, you've got a formula here. Formulas sometimes don't stick in my head so well. I have to like really understand what I'm doing. So the A is the outside, and then the A plus B is the total. I like to think of the outside times the total. So the outside times the total, and then the outside times the total. So the outside times the total. So let's see what that looks like. If I look at the 9 and the x, the 9 is the outside, and then 9 plus x is the inside, or the total. Does that make sense? So I'm going to write 9 times x plus 9. The outside times the total. A times A plus B. And then for my other side, I'm going to do the same thing. The outside, always start with the outside, times the total. So 8 plus 19. And that's the equal sign. So if I distribute, 9 times x is 9x, and 9 times 9 is 81. I'm going to add those two together. And then here, I'm going to add these and then multiply. So 8 plus 9, or 8 plus 19, is going to be 27. So I'm going to do 8 times 27, just because PEMDAS suggests that I do the parentheses first. So then 9x plus 81 equals 8 times 27 is 216. And then what's the next step in solving that? Do I subtract 81 from both sides?
Yeah.
Okay, so I want to subtract 81 from both sides. When I subtract 81 from both sides, I think I get 135. And then divide by 9. And what does x equal? Anybody get that? 135 divided by 9?
15.
15. Excellent. So how would I set up the second problem? If I want to do the outside times the total equals the outside times the total, how would I start that? 8 times what?
8 times 8 plus, wait, no.
Yeah,
3x plus 4.
absolutely. Absolutely. The outside times the total. And it's that total part that is the most often missed. And then on the other side, we're going to do 7. That's the outside. And it kind of makes sense. It goes outside the parentheses, right? And then inside, we want that whole thing. So that's 7 plus 5x plus 2. We got to combine like terms here. This is a little more complicated. Honestly, it's a little hard to look at, right? So I've got whole numbers with 8 and 4. So I'm going to do 8 times, and then I like to put my x's first. You do not have to do that, but I like to do it that way. And then 8 plus 4 is 12. And then I'm going to clean up the other side a little bit by combining those like terms. Again, I like to put my x's first. It's just my habit. And then 7 plus 2 is 9. And like I said, these are more algebra than we've done in, I think, pretty much all of geometry. So it's it might feel like a little extra. Make sure you're taking notes. If you're not good at taking notes on the Pear Deck, take notes on your paper. Okay, you can definitely use your own paper, make yourself a little notebook. So now we want to distribute. So 8 times 3 is 24x, and 8 times 2 is 16. And then we want to distribute on the right side. So 7 times 5 is 35x. And 7 times 9 is, I'm drawing a blank, 63. This time I'm going to subtract the 24x because I always subtract my smaller variables. If I subtract the 24, 35 minus 24 is 11x. I move my variables to the right this time, so I want to move my numbers to the left. Again, if this stresses you out, don't worry about it. You can do it however you want. And then 16 minus 63, 16 minus 63. Ooh, did I do something crazy? Why am I getting a negative number? Yeah. Oh, I know what I did wrong. Do you know what I did wrong? Ah, that's exactly where I went wrong. Because I can't read my own handwriting. That's a 12, not a 2, isn't it? So 8 times 12 is what? 8 times 12, oops, is 96. Is that better? And then 96 minus 63 is 33. Oh, that makes so much more sense. Thank you, Nasia. And then we divide, and x equals what? So what just happened is really important. If you get to an answer in geometry and you get a negative, okay, or you're about to get a really weird negative, go back and think, wow, I don't know if that makes sense. Just like we just did. Nasia and I had that same thought at the exact same time. I'm sure many of you also did. She was just the one that verbalized it. And then go see if you did something crazy like I did. I just didn't read my 1 in front of the 2. So 8 times 2 is very different than 8 times 12. Does that kind of make sense? The outside times the total equals the outside times the total. I don't want to rush it, but I do want to move on. Have you guys had enough time to write all that down, or enough of it down that you'll remember it? If not, please take a screen capture of it. It is my plan today to go back and give you the links to the Pear Decks. I thought, like I said yesterday, that you had all of these Pear Decks that you could go back and reference. But apparently I need to do something a little bit different. So I will be sending you those links. If you want them, you may have them. All right, so let's go into example number 4. It's almost exactly like number 3. It just has one little difference. Instead of having 4 parts, because we have 2 secants, we only have 3 parts. So it's still the outside times the total and the outside times the total. It's just in one of them, the outside and the total are the same thing. Okay, so it's still the outside times the total. So if we look at number 9, oops, I need them. There we go. If we look at 9, that's the outside, and then the total is 9 plus 16. So we'll do 9 times 9 plus 16. And then on the other side, still the outside times the total. So 3x is the outside and 3x is the total. So we're going to do 3x times 3x, which is the same as 3x squared, right? So that's how they get the a squared. It's just the outside times the total, but you square it because you're multiplying by itself. Make sense? So if we put all of this in the calculator, we can do 9 plus 16, because we like to do PEMDAS the right way. 9 plus 16, and then multiply by 9. Did you get 225? Hopefully. Okay. We've got to square everything inside these parentheses. So when you're squaring 3x, when you're squaring a number and a variable, you want to square the 3 and get 9, and you want to square the x and get x squared. So now to solve this, we want to get the x by itself. We want to divide by 9 and divide by 9. So 225 divided by 9 gives me 25. So x squared equals 25. Therefore, x equals what? What's the square root? Absolutely. Okay. X equals 5 in this part. Now, if it asked me the length of this segment, what would the answer be? Can I substitute the 5 in for the 3x and get 15? So the length of that segment is 15. That's one more layer on these kind of problems. So let's look over at the one on the right side. What would you multiply there? How do I set up my equation? If I want the outside times the total equals the outside times the total. That's the outside of the circle times the total.
Actually, I have a question.
Yeah.
How would you know which number to put? Like, would you put 24 first or 18 first, or it doesn't matter?
It doesn't matter because both sides are going to be equal to each other. That's why I started this one with the 24 and the other one with the 9. So it doesn't matter. You're just going to, like, some people like their variables on one side or the other. So you can kind of manipulate it that way. But the answer is it doesn't matter. If I start with a 24, what should the other side of the equation be? What number's on?
Times 18 plus x.
Absolutely, 18 plus x. So when I solve that, what's the first step? Anybody got 24 squared? Is 576 correct? Hopefully. And then you want to distribute on the other side. Like I said, I always put the x's first. It's just kind of math convention. You don't have to. And then 18 times 18, I need to go to my calculator again. 324. I want to get the x by itself. So I want to subtract the 324. I'm running out of room because I write too big. 576 minus 324 is 252. So 18x equals 252. And then we divide 252 by 18. And what does x equal? Anybody get an answer?
I'm putting it in real quick.
Okay.
Is it 14?
That's what I got. Victoria, is that what you got?
Yeah.
Awesome. And then they could ask for this whole distance. If they asked for that whole distance, you'd have to do 18 plus 14, which would be 32. So there are some other questions that can be asked, and I think we'll find that in the quiz right now. So any other questions on these, or should we go practice them?
Practice.
Let's practice. All right. So I already have it open, but what I'd like for you to do is to go into Tuesday's folder, because I don't know that I can give you a link for this. So yesterday's folder, and go into that homework. I want to say it was 10 questions. So I want you to open that up. I think the first question should look like this. I'll give you a minute to get there. So this first question kind of looks like our ice cream cone question, hopefully, right? So what do I do with the ice cream cone questions? If I know bx is 6, what other thing is 6?
Would it be 15?
So by is going to be 6 as well. If I knew xa is 15, what's the other side of that ice cream cone? So if ax is 15, then az is also 15. These are like the same ice cream cone. So if the left side is 15, the right side is 15. And then same thing over here. If yc is 20, then zc should also be 20. And perimeter just means the distance all the way around. If I'm running the perimeter of Mount Trashmore, I'm running around the track, around the outside of the park, right? So we're going to do 6 plus 20 plus 20 plus 15 plus 15 plus 6. Or 2 6s plus 2 15s plus 2 20s equals the perimeter. So what'd you get for the perimeter? If you do 20 plus 15 plus 15 plus 6 plus 6 equals?
82.
82. What? So just remember that if you have those like inscribed circle inside a triangle, each of those little pieces of the triangle is like 3 ice cream cones on top of one giant ice cream ball. They're all the same, each pair. So question number 2 is like example number 2. We've got an x, so we're going to cross multiply. So we're going to take one diagonal, the 5 and the x, and we're going to multiply those things together. So 5 times x. And then we're going to take that other diagonal, the 10 and the 4, and we're going to multiply those together, and we're going to set them equal. So when you solve that equation, what do you get for x? 8. Fantastic. So hopefully those were the easy ones. And if you opened it last night, you got to those and you were like, oh, this isn't so bad. And then you got to number 3 and you went, WTF, what the heck? I don't know what to do, right? But now that we've just practiced outside times the total and outside times the total, how do I set up this equation for number 3? Does it matter if I start with the 6 or the 7?
No.
It doesn't. Which one do you want to start with? Let's start with the 6. What do I multiply the 6 by?
6 plus 6.
Mm-hmm. And then I got to go over to my other side and do the outside times the total. So what do I multiply the 7 by?
Would it be 7 plus 11?
It would be 100%, 7 plus 11. Fantastic. And then we just got to clean it up. So you know if there's a constant outside parentheses, you need to distribute. So we get 36 plus 6x. I didn't change the order this time. I was being lazy. And then I can put this whole thing into the calculator exactly the way I see it because there's no variables in it. So 7 parentheses, 7 plus 11. Did you get 126 or did I do something crazy? So then if I get 6x by itself, I've done 126 minus 36, which gives me 90. And what do you get for x? 15, absolutely. And the question is asking for x, so we're done. How is number 4 similar and how is it different? How do I set up this equation?
It only has 3
Mm-hmm. So we're going to start with a 4. Outside times the total equals outside times the total. And then we're going to clean that up. So we're going to distribute. And then we're going to solve. So take a minute and solve that 2-step equation. Those shouldn't take any time at all. I've been doing those since middle school. And what'd you get for x for number 4? Beautiful. That's what I got too. And again, the question is asking us for x, so we're done. X equals 5. We got another one. Take a minute and do this one by yourself. So grab a piece of paper, you can screencastify, however you're solving problems these days. I'm going to give you exactly 1 minute and see what you get. 1 minute always seems so long in silent Zoom land. Somehow in the classroom, it doesn't feel like that much. So if I do the outside times the total, I'm going to do x times x. And then outside times the total, 4 times 4 plus 5. So x times x is x squared. And I can put this whole thing into my calculator or do it in my head. 4 times 9 is 36. So what's x equal?
6.
Yay! Did everybody get 6? Somehow it's oddly gratifying to me when you get the right answer on something that just 12 hours before you were like, what the heck is that? I don't know. All right, so now we've got an x. How do I do the x? So I multiply or divide? Multiply. So I kind of think of cross multiplying here. It's not exactly cross multiplying, but it's close. So I take one of the diagonals and I multiply those two pieces together. So 6 times 6x. And then I take this other diagonal and I multiply those two pieces together. So I've got the circle diagonal and the rectangle diagonal. We're going to do 8 times 4x plus 1. And it just makes my life easier to put the whole numbers on the outside and the variables on the inside. That's just, again, convention. It doesn't really matter. It's just easier to look at. It's more what you're used to. So if we do the multiplication, because we're just going to solve these equations, 6 times 6x, 8 times 4. Oops, I forgot something. There's a 6 in there. 32x. Plus 8. So make sure you're solving in your seat, just like I'm solving in mine. If you're doing that on paper, do it on paper. And so what's x equal? 2. Perfect. Perfect, perfect, perfect. Are we starting to build some confidence here? All right, drum roll, please. How do I do number 7?
You do outside and then times outside times plus inside.
And then the total. Perfect. So outside is 9x, and then plus the outside plus the inside. I like that. And then the other side, the outside of the circle is 10, and then the outside plus the inside. How do we solve this one? Let's solve this one together. What do you want to start cleaning up first? We've got one side that's all variables and one side that's all numbers. Which one's easier to clean up and simplify? I would 100% start with the numbers because I can put all of that in my calculator. So 10 times 10 plus 8. In my head, I get 180. Is that correct? Hopefully. And then over here, I'm going to revert back to PEMDAS. So I'm going to add those up. 9x and 11x is 20x's. And then I'm going to multiply. So I've got to multiply my numbers. 9 times 20 is 180. And then x times x is x squared. If you're going to make a mistake, that's where you're probably going to make it. So when you multiply two variable factors together, you want to multiply the numbers and multiply the variables. Equals 180. Now it looks kind of scary at the beginning, but somehow equations have a way of making themselves very simple a lot of the time. So x squared equals 180 divided by 180. I have 180 students and 180 donuts. Everybody gets one donut. And then we're going to take the square root and take the square root. And that whole big scary equation ends up being x equals 1. Again, that's kind of like one of the magic things about math is you take something that looks so complicated at the beginning and it boils down to something so simple. Questions on number 7? It's this part that usually messes people up a little bit. 9 times 20 is 180, and x times x is x squared, not 2x. Okay. So make a mental note of that. Put it on the sticky side of your brain so you can remember. This one, we're back to our cross multiplying or our x multiplying. So what two things do I multiply here? I've got a GE, maybe somebody I haven't heard from yet today. I've got a GE and an FH. What two things do I multiply on the one side and what two things do I multiply on the other side? Dun, 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 dun. Okay. I'm going to take the 21 and the 18. So 21 times 18, they form one of my chords. 21 and 18 form the GE chord. So GE, I got to multiply those two pieces together. And then I've got FH. So I need to do 14 times 3 plus 4x. Right? So I take the GE chord and I multiply those two pieces together. And then I take the FH chord and I multiply those two pieces together. All we're doing is multiplying the two pieces and setting them equal to each other. Then we just got to clean that up. So 21 times 18. I love it when there's something easy. I can just put in a calculator. That is 378. And then you're going to distribute. So 14 times 3, is that 42? And then 56x. I feel like maybe I should put that 14 times 4 in the calculator just to make sure. Oh, it is 56. Love it. So then we're going to solve that. I don't know why I keep hitting log. 378 minus 42, and then divided by 56. What did you get for x? I've lost everybody. The crowd went silent. Did you get x equals 6?
Still doing it.
Okay, I'll slow down.
What was the question?
So did you get x equals 6? Did I solve that correctly or did I do something crazy?
Yeah, that's what I got.
Okay.
That's fine.
Is that my final answer or do I have to do something else?
You have to do
You have to plug it in into LH.
Absolutely. So LH is this piece right here. So I need to plug that 6 in right there. 3 plus 4 times 6. And what is 3 plus 4 times 6?
It's 27.
It is 100% 27. Absolutely. So they've lulled us in the first 7 questions to just solving for x, and then they've thrown at us a find LH. So always before you submit something, before you move on to the next problem, make sure you're answering the question being asked, because it would really stink to do all of this beautiful work, give them x equals 6, when really they want LH equals 27. Okay, so just be careful of that. All right, number 9, I'm going to give you a minute or two to do this one on your own. See if you can set it up. Inside times the total equals or outside times the total equals outside times the total. See if you can work this out on your own paper and see what you get. So everybody should be trying to work out number 9 on their own piece of paper or their computer, however you work out problems. And then I'm going to start to work it out. So compare yours to mine as you continue to work. I usually start from left to right. So 32 times 32 plus 18. And then outside times the total, 10x times 10x. And then you can either distribute or you can combine like terms, but either way, I think you should get 1600. So if you're still working, look up at my screen for a minute. 10x times 10x, I've got to multiply my 10s to get 100 and multiply my x's to get x squared. Did everybody get 1600 equals 100x squared? Hopefully. We're going to want to divide by 100. Divide by 100. 16 equals x squared. Take the square root of both sides, and x equals 4. Am I done? What do I have to do?
Replace the 4 with the 10.
Absolutely. Absolutely. So I've got to put the 4 in here. And so what's my final answer for ML? 40. Absolutely. Okay. It's this step right here that will get a lot of people. Some people will say 100x instead of 100x squared. And some people will say 10x squared instead of 100x squared. You need to make sure you square both parts of your term. Okay. All right, last question. And it's kind of the Mac Daddy question. You want to do it on your own to see if you can do it, or you want to do it together?
That's not the last question.
Oh, it's not? Oh, dang. There's 2 questions. All right, in the interest of time, ten times, what do I write in the parentheses? Hopefully you're predicting what I'm going to write. So I've got the outside times the total, right? And then on the other side, the outside times the total. Outside times the total. So then when we clean that up, we can do 10 plus x plus 16 equals 9 times x plus 19. However you do that. And then 10x plus 160 and 9x plus, anybody got 9 times 19? Awesome. Is that 11? And then you got to find SU. So what's SU in this? SU is that whole distance from S to U. So you definitely want the 9. That's UT. And then how long is ST?
ST is Oh, I just got it. 21.
21, absolutely. So if ST is 21 and UT is 9, what's US?
30.
29?
30.
Oh,
21
32.
plus 9 is 30. Yeah. Okay. So lots and lots of steps here. Take your time, pay attention to the detail. That's what this kind of problem is teaching you. You're never going to use this in real life. I know that. I'm perfectly aware of it. What this problem is teaching you to do is go through a systematic process and make sure you're paying attention to all the little details. Okay? And hopefully that skill will translate over to later in life. So question number 11, this is finally the end. What do I do here? We're back to our example number 2, cross multiplying. What do I multiply together?
8 times 15.
8 times 15. I love the confidence in that answer. And then what else?
12x times 10x.
Absolutely. So 8 times 15 is easy. I can do that in the calculator. That's 120. What do I get when I get 12x times 10x? Remember, you're going to multiply your numbers and multiply your variables. So 12 times 10 is 120, and x times x is x squared. Again, the 120s cancel out, and x squared equals 1, so x equals 1. What was the work for 6, 5, and 4? Okay. I have questions about question number 6.
That's not the answer, though.
That's not the answer? Why is it not the answer?
Look at 1 p.m.
Oh, dang. Good catch. So PM is the question, not X. So what do I do? Been doing it in the last 3 problems. We want to substitute in, right? So it would be 10. 10 times 1. Good catch. I would have gotten that one wrong. Okay. So we did 10, 9, 8, 7. This was the work for 6. If you want to screen capture that. I will post this video in a minute or 2, so know that. And then this was the work for 5. Outside times the total equals outside times the total. And then 4 was right here. Again, outside times the total equals outside times the total.
Thank you.
You're welcome. All right, so there is a circle segments practice for homework, guys. This is what I want you to work on. If you have not added to the media albums from Friday, I need you to do that. So media albums from Friday. Any questions on the IXL in the last 5 minutes of class or on the media albums? Do we want to talk about any of the IXL skills? We've got about 5 minutes.
Are there any office hours anymore?
Mondays are office hours. So Mondays from 2 to 3 office hours. You can come see me during boot camp. So if you want to talk about this and not the boot camp stuff, you're welcome to do that. Just come like not at 2 o'clock, come at like 2:30 and we can go in a breakout room together.
Okay. What IXLs do we have to do?
The U's and the V's. So if you
All of
look,
them?
you need to get 300 points on the U's and 500 points on the V's, I think. So there's like, that's like getting all of them to 50 or, 3/4 of them to 80.
Okay.
And I know it seems like a lot, but a lot, like the first ones go so fast, you can get 100 pretty quickly. I was thinking that the assignments would pop up here. I don't know why it's not loading. Oh, there it is. Oh, it did go away, didn't it? So I think if you look in Friday's class or Monday's class, let me change the due date on Monday so you have that.
Okay.
Nope, that's not where it is. Any questions on these media albums? Are we adding things to those?
Can you go over one of them and just central?
Inscribed? Absolutely. I'll find the IXL assignment and post that, repost that, so that you know exactly what you need to do. And then the media albums, we're in this one, right? So central and inscribed right here. So remember, central angles go to the center of the circle. So in this one, it's the arc is 60, and then the central angle is going to be 60. So those are going to be exactly the same. And then the X and the Y make a linear pair. They make 180 degrees. So the Y part is going to be 120 degrees. And then if we look at this angle, which you can kind of barely see, I'm highlighting in red. The Z is small, right? And the arc is big. So their relationship is one is twice as big as the other. If the 60 is the big thing, then the Z has to be 30 degrees. It's half the size. Does that make sense? So that's how you go about that kind of problem. Let's go to the next one and see if we can do that one together. And this is kind of almost exactly like the ones on IXL. In fact, this might be straight from IXL. So if I know this interior angle, the central angle is 152, what's the X going to be? They add up to 100. They add up to 180. So 180 minus 52 is 28. Which means this arc is 28. Because those are going to be the same, because that's the center of a circle. And then this angle is small. And then this arc is bigger. So Y is going to be half as big as the 28. So the Y is going to be 14. So the central angles are congruent. The X and the 28 are going to be exactly the same. And then the inscribed angle, the one that touches the edge, is going to be half as big. This one's half. Okay. It is 8:50. I want to be respectful of your time. So that is going to end class for the day. You guys work on that quiz, and we'll talk about that tomorrow. And then we've got one new thing to learn tomorrow, and then we'll be done with circles. Have a great day, and I'll see you tomorrow, guys.
Oh.